Alright, physics video. Interesting. Why is that moving? Pendulum. Really quite, Squirrel must have done it. But, it's kind of, frictionless that it's still moving. Even though no sign of the squirrel or the rabid monkey or whatever. Anyway, yeah, so this just overviewy kind of thing. I just throw this in for the sake of it, I suppose. Conversation about what somebody's required to, what kind of proof is necessary to establish an idea. I was sort of thinking about the Gould guy when he came up with punctuated equilibrium as an explanation for why the fossil record is doesn't contain a bunch of intermediate stages of development, and that the idea is basically that small breeding groups are responsible for the mass of evolution, that a small group goes off, does it their way, and they fall upon a change in behavior or a change in physique, let's say, based on isolating their DNA and inbreeding, perhaps. And I don't think he added the inbreeding part, but I'll throw that in. And this creates more variation, more potential for a happy accident. And then that small population becomes successful. And then once it gains some success, then it challenges the hierarchy. It challenges the mass breeding population. It reinvades the population it was a side crop from, and that new DNA, that new structure, that new design dominates and takes over very rapidly. So there's no fossil records because the population is so small where all the evolution took place, and the change just kind of shows up later as a fairly developed change. Well, anyway, I don't want to get into that whole subject. The point being that you can propose a change to a perception of how something works that may not necessarily change the structure, but does, it makes a significant change, and there may not be any way to prove the mechanism, practically. You can't just do it on a piece of paper, let's say. So I'm sort of in that position where I am challenging the what's identified as causes of effects. I'm saying that matter is made of energy. The energy is still energy. It's still moving the speed of light, and that's the reason it can't do certain things. It's because it's already doing certain things. It's already moving the speed of light, and for it to move somewhere as a group, it has to do so proportionally. Part of it has to do that movement, and that will occupy time. So anytime you acquire velocity or movement in a direction, some portion of your structure has to be devoted to going that extra space, to creating that extra pressure in the direction. So instead of doing what they were doing, which was doing some certain thing in space, in time, they're now adding this extra movement. And that's what dilates or slows everything else down, is that it occupies time to move in a direction, to consume space. So that's not really what I want to get to either. The point is I'm making the argument that the material universe gets simpler as it gets smaller, not more complicated. That's why I would argue that phenomenon like the spooky action at a distance, the entanglement and other mechanisms, likely, from my perspective, we'll find some other explanation than the explanations commonly grabbed at, because these other explanations impart a complexity that I don't think can exist in a simpler mechanism. What makes the universe work is not complexity, but the gross amount of it. There's so much of it, and that's what challenges us perceptually, is we can't grasp the vastness of the amount of interactions taking place. So we complexify them through the filters of our brain just because of that, even though the mechanisms that are really at work are simple and mechanical. So it argues something like chemistry. You watch some chemical reaction, you can't intuitively sense the mechanical simplicity of the fact that it's just these mechanical chemical arrangements, molecular arrangements that are binding to each other through very logical and mechanical ways that are creating the reaction. They don't look like that, crudely, but we can understand that that's what's happening. That isn't magic that pulls DNA molecules apart, and that it isn't, that there is a mechanical mechanism, a simple mechanism, simpler than what our brains tend to imagine, let's just say. So anyway, where do I want to go with this? It's just disappointing that people think physics is math. When physics is like any other subject, it's a model, a description of how things interact with each other. And it can be, you can describe anything mathematically. I could describe this walk mathematically with vectors. I could reduce it to geometry and give you some equation, for how much deviation there will be over the length of the path and all of that stuff. Now, that doesn't show it. It doesn't reveal it. And, it'd be easier just to say, look at it. You can see it's crooked. So there's no dependency to provide complex explanations of how the deviance of the path could be. And certainly, I guess it doesn't obey rules or laws. So, it'd be different in that sense, that there's no predictive value. The path could go off to the right or off to the left. There's nothing stopping it. Alright, so I need a different example. A better example, maybe. I have to think of one off the top of my head, which probably is just pointless. So I probably won't do that. I don't want to, who wants to waste their time talking about, what's an allowable diagram, how complex the diagram has to be. Maybe that's the way to argue this. Again, the premises and the statements being made aren't undoing what is much of what is established. Let's say 80% of it. It's just re-explaining the cause of it. And for the 20% it is changing, unfortunately it is in very obscure areas, very hard to access places. How you doing? Hey, pup. You can't change. You can't. I can't access something moving 3/4 the speed of light and show you how its actual matter is not liking its circumstance. How the matter there's a point where it is dependent, on its pieces staying coherent, and that the coherency will be lost. Like when it tries to produce a beam of light or a coherent stream of photons. If it's moving very fast, the stream of photons it will produce will lose distance between each other, and at such a substantial rate that there'll be no eyeball big enough to recognize or resolve the pixels. So there's so many little nuanced subjects that are built into all this stuff, but we have to even recognize that our eye perceives something, and there's a little bit of fuzzy logic being applied in the sense that the photons don't have to exactly follow each other, so they can be out of alignment, a little in terms of the stream in which they flow into your eye. They can be vibrating in slight directions, and our eye won't perceive that. Our eye will just categorize them as a coordinate in a resolution, and it'll just turn them into a pixel. They'll be on or off. So this image here can be resolved with this camera. It's reducing reality to 1,000,000 pixels or whatever it is, and it's a small number of on-offs in terms of a color, let's just say, the color information has a lot more bits, but it doesn't add more pixels. So it's resolving an image by reducing it. There's more pixels available. It's just saying that anything that falls in a group of space, that falls into a category of space, will be counted as part of the frequency of that light, the color of that light. That's the detection process. So there's not a, how to put this, so I don't think there's any explicit requirement, but we do know that if the light is too far separated, too fuzzy, our eye won't resolve it as light. It may have the right frequency, but if one photon's here, and one photon's over here, and one photon's over here, and one photon's over here, even though they're coming at the right frequency, if they're too far from each other, laterally, supposed to be the right word, we're not going to resolve anything. We're not going to see anything. So that isn't going to work. What else? So that's part of this. There's all these little, I'm just pointing out that there's, the complexity is in, defining characteristics of things that we can't see, and we can only see indirectly. And so we have to try to figure out what they can and cannot do. What things are or are not doing. And it's easy to make errors in those deductions of the cause and effect stream, to get it wrong. And, and that's, it's just easy to do, just because you're getting such a, there's such an insufficiency of information, and there's more than one model that'll fit the evidence, or the effect produced, and the divergence in those models is not insignificant. Yeah, it's important. So what else? Pool getting closed tomorrow. Too cold for swimming today anyway, but disappointing. Summer has passed. Oh, yuck. So, what else to say? So this is all significant. I'm just saying that there is every probability I mean, I can make all kinds of predictions. Some of them are even predicted. I predict nothing, no material substance will ever travel the speed of light. There's a prediction. You know, what value is that? Nothing. I can predict time dilation in the sense that I will predict that acceleration or momentum or velocity will slow your atomic metabolism down. Atoms will, electrons will circle atoms. It will take longer for them to do it, okay, as the matter moves faster and faster. I will predict, well, there's no point in me making up my predictions, but I'm sure there can be some predictions. I predicted a lot of things about the two-slit experiment, if it can ever be done the way I would like it to see it done. It's already been done to some extent. I mean, there was a guy who demonstrated the eraser effect, in some of these light polarization and whatnot. And but that's another subject where there's a nuance. People assume that when you put a polarized filter, that all the light is perfectly polarized that comes through the filter. And it's not perfect. It's just saying that light is, any one of these angles is allowed. This much, too much, more than 45 degrees, you won't get through. Less than 45 degrees, you will get through. So even though you're not vertically polarized, you'll get through a polarizing filter, even if you're a bit off. And that through that process, you can in fact create filters that will bend light, because the ones that are close to that angle of not inclusion will be pushed, but they can only be pushed at a certain number of degrees. They can't be pushed all at once. They have to be pushed in stages. Changed. Have their angular momentum changed. No, the polarization isn't angular momentum, but anyway. Point to point. Yeah, so I just find this disappointing that people are not arguing the model I'm providing, saying why this model doesn't not only fit the evidence, fit some substantial portion of the mathematics, and that all it's challenging is underlying assumptions, wrong assumptions. And I will find areas where what I'm saying will provide, probably in some respects, an explanation or a proof, quote unquote, regarding some element of what is being said, and my theory will provide explanation for why that effect exists, and that will provide some measure of verification. But it's this whole idea that you prove it by having one instance of compatibility. You really should require more evidence than for an absolute proof. But certainly you can't disprove a theory by simply saying, I don't like it, or you didn't prove it. Saying I didn't prove it doesn't prove innocence, kind of thing. You know what I'm saying? Going into a courtroom and saying he didn't do it doesn't prove he didn't do it. It just doesn't. It certainly doesn't prove he did it either. If you don't have evidence that he didn't do it, that doesn't prove that he didn't do it, kind of thing, or did it. Alright. Hey, pups. You can't. This whole idea that I'm being, I'm saying they're just making the argument from, well, until you provide us, with photographs, we're not buying it, or some sort of, again, I should duplicate somebody else's mathematics. Not much point in doing that. So I have to figure out what portion of the mathematics is, wrong. And yeah, maybe someday I'll have time to do that. But right now, I'd say it would be a waste of my time, a waste of the time I need to devote to coalescing all the implications of the argument I'm making. So yeah, I'm not going to waste my time with that. But I certainly shouldn't have to waste my time with people saying you're wrong merely because you haven't proven yourself to be right. Or in some way. I suppose I will. Like I said, the easiest challenge will be to find some disproof of the counter theories. Some circumstance, some paradox created by it. And there are lots of those for general relativity. And I can certainly point out it's, that it has no coherent model for its creation. This, space warping by magic theory versus a matter warping because it's being bombarded by a pressure. I think those two arguments, one will eventually be seen to be much more viable as an explanation, as it provides a real explanation that is coherent to what we really observe, which is things cause things to do things, not non-things. Anyway, something makes something do something, not nothing. So, yeah. Until next time. Having a bit of a crappy day. Not feeling like it. I feel like not having this day. So, till next time. Painting garages and such. Yuck. Well, there are worse jobs. Whoa, I'm back. You have a little add-on, what the hell? A little after-work add-on or whatever. Stream really is quite full of matter. There's a tire over there. Oh, that's pretty funny. In the middle of nowhere. It's almost like somebody had to throw it out there. Maybe somebody put it out in the ice and it fell through the ice or something. Maybe that's it or something like that. Disrupting the gooses. Little shit monsters. It's a nice little bench they put out here. Doesn't get much service. Memorial to a little kid who died in a fire. Less than like 500 yards from the firehouse. Why the fire department was burning Christmas trees. But anyway, lots of silly ironies in life. So where were we? Yeah, it's just quite lovely here. Nobody to bother me today. Yeah, it's just ideal, actually. Except for the noise of the leaf blowers and whatnot. Cigarette. Yeah, it's good news about work. Sometimes there's people at work who smoke, so I win. Anyway, yeah, so just an overview. I guess it's it is kind of funny about like the Einstein story. You have to get it from letters and little bits and pieces of what happened. And nowadays, somebody's evolution of their philosophy or their ideas, it's all recorded now. It can be anyway. It's kind of like that with YouTube and these 3,000 videos I've done. It's all the whole evolution of the argument is right there to be seen in a way. Nobody needs to redo a documentary and do a whatever the word. I know there's a word for that. I'm just tired. For a non-first person biography, a third person point of view or whatever. Somebody needs to weed here, I think. Maybe I should do that someday. There were a bunch of turtle eggs here that got dug up. There's the remnants of a few. Little snapping turtles. Probably didn't make it. Yeah, to the next generation. That genetic pile didn't go anywhere. Probably. I suppose some of them might have made it to their life in the pond. No. Anyway, I guess I don't have much else to say. So, until the next time, and such and so forth and whatnot. Good shit. Yeah, shit. It is really quite nice here. I'm very lucky. Anyway, it's not a very scientific thing to say. So anyway, but yeah, I mean, I will defend. I think I've got something. And, I'm going to defend it as a better explanation of reality. All this stuff is photons, just trapped in complex spirals. Complex only in the fact that there's so many connections between them. It's probably it's like color. You know, color is only made up of the 3 primary colors, and yet you have all the variety of color. And it's the same kind of system in the core of the nature is of physics. It says 10 properties, but there's just an infinite variety of form you can create out of those 10 properties. Wow, that's a neat hole there. See, that might have been a turtle too. Dug its nest in there, and then something dug it out when the eggs hatched or something. There's no sign of eggshells anywhere, so probably not, maybe not, who knows. Look at the crud in there. You get, but not much life, which is irritating. I've tried to video something. It's just murky green crap everywhere. So not much action in terms of biology other than the plant life. You know, which isn't a great sign. You know, but it's like that. It's been declining biology here for the last decade. So, yeah. New World Order and such. Yeah, well, enough of this. Yeah, somebody needs to sweep down there. Yeah, maybe I'll do that someday. There's a lot of things that I might do someday. Yeah. But not today. I'm tired. So, until next time. And such. I don't think there's going to be anything down here to get close and say, ooh, look at that. Something cool. Ooh, look at that. Something cool. Nope. Nothing cool in there. Could go to the other side just quickly. Boy, the cars are so quiet now. That's a real... one of the threats is you don't hear the cars coming. Because they don't clank down the road. Ooh, looks all just kind of murky. A lot more fish in here though, which is nice. But yeah, the water's just kind of stale.